Hey everyone, thanks for joining us here today. Wherever you are in the world, welcome. Good morning, good evening, good afternoon, anywhere in between. We are here today to talk about profiling. We're here to talk about what you can do in your Unity game, Unity project, to make it more efficient so that you can actually deliver the game experience that you wanted to deliver for your players, so that your players can actually go hands-on with your game and get the performance and the profiling and the experience that they expect from a game from you. And so today I'm actually joined by some amazing guests from game developers, partners, and our own Unity engineers to talk through some of the tips and tricks, the do's and don'ts around profiling. This is a fantastic opportunity to do a little bit of a deep dive and get some insight directly from the minds of people who have been there and done that, who have experienced game development and the pains of a game not performing to its best, and some of the things they found actually can really help them actually do that. We are going to focus on a little bit of mobile and a sort of platforms based profiling as well, but there are a lot of general tips here, a lot of really good coverage to make sure that you can do what you can to make your game perform. So that's my really quick intro. My name is Andrew Parsons. I am the product marketing lead for programmers here at Unity, and I used to be a programmer myself. I know the pains of my applications not performing to their top quality. So I'm looking forward to this chat as well, hopefully just like you guys are. So with that, I want to introduce my wonderful speakers that I have with me. I'm just going to run down this list, and team, if you could just sort of go off mute and say hi when I call out your name. Actually, let's start with Paul Georges. He's one of our software development consultants here at Unity. It helps customers, partners, users like you guys and gals to really get the most out of your game. So, Paul.
Hey everyone, welcome.
Great. Peter Harris is from ARM, and Peter's going to be one of our massively awesome experts around mobile optimization and Android optimization. Peter, you want to say hello?
Hi, everyone.
Awesome. Ramiro Bazan is the lead game engineer on Cybo Games. You may know them from Subway Surfers and other things. Ramiro is going to really give us a deep insight into how it is on the real, on the coalface of actually game development and making sure that games perform across many, many different types of devices. Ramiro?
Hello, everyone. Nice to see you.
Great. Thank you. And then finally, not least, but finally, Steve McGreal, someone who I spend many, many hours talking with because he's such a great guy. He's a senior software engineer here at Unity. Steve.
Oh, you. Yeah, no, thank you for having me. It's going to be interesting, I hope.
Awesome. Thank you. Thank you, guys. So this is our little roundup, our little panel. I do want to encourage you to ask questions in the Q&A section. I've got some great team in the back house, Adam and Madison, who are going to help us moderate that and feed the questions to us so we can answer your questions, as well as the questions we have for each other right now. So let me talk to you about what we're going to talk about, right? This is the standard sort of slide of the thing about profiling and what it means for you as a developer, as a creator, and why it's important. What are the business implications of poor performance? And then that obviously helps us understand what we can do and why we need to do it. Some really actionable strategies for approaching performance optimization through profiling, and some of the don'ts. There are things to avoid. Things are a bit of a waste of time, but other things that you might not want to actually do. It might not improve your performance, even though the profiling is telling you to do something. So we've got some things there. And then some very specific tips and tools on optimizing performance specifically for mobile and Android specifically. As you might imagine, our ARM expert here is going to be able to help us there. And then some final thoughts, anything that sort of didn't fit into any of those categories, I want to make sure the whole team has a chance to sort of give their own little personal view. I might ask some curveball questions as we have time. And obviously we'll have time at the end to sort of field some of the questions that I might not have actually been able to broach during the conversation. So I think with that, we should get started. And I'm going to stop sharing my screen so that you guys can see everyone. And let's go for it. So I think, why don't we start with the business impact? I want to ask Ramiro around Cybo and Subway Surfers and stuff. Why did you approach profiling and performance optimization? Like, what's the impact if you don't do performance tuning in your game?
Yeah, sure. So originally, so historically, you have to think that Subway has 10 years old. So we have a huge catalog of devices that we have to maintain. And at one point, the devices that we are categorizing as low-end devices were actually the high-end devices at one point. So we have to maintain the performance and actually try to keep all the KPIs that we're going to talk about in this webinar, like temperature, battery usage, network usage, disk, like I/O operations. We have to keep them optimized so we can actually provide the users to the experience that we are actually trying to give them. So they can actually play for a long time without actually affecting their device. So we don't want to be that app that is actually draining your battery and then suddenly you have to run and find a electric plug to charge to continue playing. So like the session time that we are trying to aim is around 20 minutes. So that's people, sometimes we have hardcore users that are actually playing 2 days in a row. So nonstop. So we have to be able to give that, that kind of experience. So profiling for us is something that we do before, during, and after. It's like a way of living, let's say.
Mm-hmm. And I know you sort of touched on it a little bit, but I feel like no, with Subway Surfers being downloaded, what, 3 billion times or so, just a few. I know that some of those people are going to be on actually low-end devices, right? And so, can you talk to a little bit about why it's important to reach that particular segment as well?
Yes. So if you want to categorize the devices, we categorize devices in some way. We don't specifically code things to give different experiences because we want to be like neutral. We want to give everyone the same good experience. So we are not actually doing things that are only available on high-end devices. We try to optimize the game as much as we can to actually provide the same experience to low-end devices. But low-end devices in general are a huge revenue source, because if you think how the recycling of the devices work, actually users are actually getting devices from someone else sometimes. Like, for example, I will give an example. My niece is actually getting the device from her mother because her mother wants a high-end device. So she gets the bad one. And the game should actually run because that is one of the sources from us, for us as a revenue. So that that's all.
Yeah, and I was going to say, and possibly geographical sort of limitations as well, right? Some countries, low-end devices is the norm for all users, right? Yeah. So
yes, exactly.
That's a big business impact, I think, that you need to be considerate about approaching when you build your game. Don't think about that great Samsung Galaxy S20, that Ultra that you're using for development. Think about those other devices as well and what you need to do to make sure they work. So that's a really good opener for us to talk about there. Do you actually use, Ramiro, do you use different type of hardware tiers to do your benchmarking, and how does benchmarking factor into profiling for you?
Yeah, so basically what we do is to separate. So what we call a low-end device, let's say that we have the lowest tier, that's what we use actually for profiling and benchmarking the features that we are delivering. So it should work as good as in a high-end device, in a low-end device. So for example, just for saying one device. A Samsung S4 that I used to have when I was younger, I was amazed with the speed of that device. Now it's our baseline for Android. If you want to actually make a new feature, you should actually work as expected there, like rendering wise, battery wise, CPU wise, and memory consumption as well.
Yeah, that's good insight. I'm going to switch a little bit because I want to talk about, from a business perspective, maybe some of the hardware trends we're looking at as well, and how do we actually sort of target future thinking in terms of our profiling as well. So Peter, I'm going to put you on the spot for this one. Do you want to talk about any kind of sort of hardware market trends you're seeing and what that might mean in terms of strategies for profiling?
Yeah, certainly. So I think the most interesting hardware trend in the last 2 or 3 years has been a real emergence of kind of dedicated chipsets targeting mid-end. So I think if you go back 5 years, you kind of had your top-end handsets that had really high-spec GPU configurations, and then kind of void in the middle, and then sort of entry-level phones that had much smaller kind of chipsets, 2 shader cores rather than 10, 12. So there was this kind of gulf in the middle that there really weren't devices targeting that space. And I think what we've seen in the last kind of 2-3 years has been this sort of sub-premium market, which is dedicated chipsets that are sort of not quite as fast as the latest top-end phones, but they're still really super capable devices that can kind of give you all the latest features on a slightly smaller configuration. So that makes it a lot easier to kind of push kind of graphically rich experiences into a much larger player base. So I think that's probably the biggest hardware trend that we've seen in the last 2 years.
And I mentioned earlier, but what about geographies?
Yeah, so geographies definitely make a difference. So in terms of device availability, which you've already mentioned, obviously some markets have less available high-end devices. The other big one actually from a profiling point of view actually is temperature. So for mid to high-end phones, they all suffer from thermal problems. If you run those devices flat out, they're going to overheat. So an identical device in the winter in Iceland is going to behave very differently to a device in the summer in Brazil, even though the hardware is the same. Their ability to dissipate heat is going to be different. So understanding the sort of geography of your players and where they're playing is a really important part if you really want to get the peak quality out of these devices inside a kind of stable performance envelope.
Yeah, that's actually a really interesting insight, Peter. I wonder how many developers actually think about, hey, my device works great here in, sunny Sydney, but if I went to, icy cold Finland, northern Finland, like it might act a little bit differently. Yeah, interesting. Okay, Paul, I'm going to give you a chance to speak some words of wisdom. And just to frame up right at the beginning, I want to ask you, everyone talks about frames per second, right? Where, I'm targeting 60, I'm targeting 120, I'm targeting whatever. But why is frames per second perhaps not the best metric, or it's a deceptive metric to consider?
Right. So that metric is useful when you're trying to attain a target frame rate. Say, for example, you're targeting 60 frames per second or 30, depending on the device you're working on. This is very much a metric that's tied to screen refresh rates. That being said, it's not the most useful metric when actually determining how much time a system is actually consuming on CPU or on GPU. So to give you an example, I'll actually cite something from the ebook that will be shared during the webinar at some point. But say, for example, you have a game that's running at 900 FPS, so something really quick. So this is actually going to be consuming 1.1 ms per frame. And say, for example, then you add a system that's going to consume an additional 1.1 milliseconds to the total frame time. That's going to drop your frame rate to something like 450. Whereas if you have a game running at 60 frames per second, or an equivalent of like 16.6 milliseconds per frame, you're actually only going to reduce your frame rate by a lot less. So you're actually going to be running at 56.25 frames per second. So what this means is that depending on how much systems that you're adding to your player, or your application are consuming, it's actually going to reduce frame rate and change frame rate variably, because these things are inversely proportional to one another. So whenever you're profiling something, you're adding new systems, you're modifying systems, ensure that you're using a profiler to actually determine frame time and use that as a metric to determine whether or not you've improved performance in your application or not. Otherwise, frame rate is useful for really determining if you're hitting that target frame rate that you're looking to hit.
Good. I think that's an interesting point for people to think about is, frame rate is not necessarily the be all and end all. And you've got to do some balancing of what other things might matter to you and to your players in terms of experiencing your games. And Steve, I'm going to give you a question as well, and then I'm going to jump back up to Cybo, guys. For you, it's like right up front, when should you profile? Like when's the best time to start profiling and optimizing?
So with the caveat that you're talking to somebody that basically profiles Unity projects for a living and enjoys it, like all the time. Now, start profiling your game right now. To put that in sort of slightly more sober terms, like early and often, essentially. Like I think you maybe have a little wiggle room at the start of a project when you're in like pre-production and maybe you're concerned with kind of like experimenting with gameplay features and stuff. But even then, like if you're building something where a core feature of your game is something that might actually stress performance, so I don't know, like if it's like using crazy fluid physics, or if it's like using a really high resolution voxel engine, or one of these things where you're actually going to push the boundaries of the hardware a bit, you want to profile that as soon as possible, because that's about de-risking your project. That's about going, what is possible on the target hardware? And then throughout production, really, certainly before and after making like significant kind of changes or implementing big features, perhaps if your team runs on a kind of an agile schedule, and you have reviews at the end of each sprint, where you get the team together to go and look at the game. Perhaps you just need a second screen there with a profiler running just in the background to help spot any changes since the end of the last sprint. I think what happens is sometimes profiling is a bit of an afterthought, and you're kind of in crunch, and you're hopefully not in crunch. Hopefully you're working somewhere with a healthier work environment, but you're in the final push to get the game done. Your bug database is full of all stuff, and then someone realizes that the game's running at 15 frames a second, and it comes down to one programmer to like fire up the profiler and figure out what's wrong. And by that point, you're too far into the changes you have to make are too big and too risky. Whereas if you'd made those changes 6 months ago, it would have been easy. So
I know some people are concerned about using profiling tools in themselves impacting performance. Do you want to talk a little bit about how the Unity profiling tools may or may not impact performance as you're testing?
Yeah, well, so they're particularly with the kind of with something like the Unity profiling tool, that's an instrumentation based profiler, right? So the engine runtime inserts profiler markers into parts of the frame. And so if you have, for instance, very deep call stacks or other features which mean that you're inserting a lot of profiler markers, that can kind of artificially impact performance. One example with the Unity profiler is if you turn on deep profiling, which gives you the full call stack all the way down, which is really helpful when you're trying to diagnose specific problems, but also has a huge impact on the frame. So in that sense, everything that you're looking at in a profiler, or certainly with an instrumentation-based profiler, I think even to an extent with a sampling-based profiler as well, you're never quite seeing the reality of what it would be like in a kind of release runtime thing. But like, I think that the goal of profilers is always to minimize that overhead as much as possible and to give you as accurate a picture as it's possible to get. And so hopefully if you have profiling tools that you can trust, you can pretty much treat those as gospel. Like it doesn't, you know,
Yeah. No,
it doesn't hurt to do that.
I think that's a fair point. And I also, I want to take one little nugget out of what you just said there, which was different profiling tools and activities can give you different types of insight, right? It's not just like one shop, one size fits all type thing. It's, like you just said, deep profiling gives you all this really deep insight to find out this one little specific thing that's giving you a bottleneck, versus that very high level instrumented profiling where you can just say, oh, my GPU is my bottleneck. Let me dig into that a bit more. So there's that kind of thing too. That's great. So thank you for that. Ramiro, I am going to turn back to you. I actually have a user question, a viewer question, I should say, that's kind of in line with what we were going to ask anyway, which was things like, okay, I'll just read out the words. What devices do you use to profile, like what hardware devices do you use to profile with to represent your 3 billion players? And do you have any recommendations on how to determine which devices you should profile against?
Yes. So let's start from the point that it's impossible to cover the 3 billion users we have because we don't have the infrastructure to buy so many devices and hold them in a room. And also you have to think that depending on what geo you are, there are a lot of weird devices that I actually discovered when I started working for Cyber. I didn't know that there were so many weird devices in the world with weird combinations of hardware. But what we do is we take, of course, some baselines, as I said. So we have the low-end devices and the high-end devices. Of course, for Apple, sometimes it's easier because they have around 20 devices. I don't know, 25, 30. And from that set, we actually take a subset that we support based on what is the minimum OS that we want to support. In this case, we support only from 10 to 16 in this case, because it's a beta. But for Android, that is the complicated actually universe. What we do is as well, we take the minimum OS, we take one device or a few devices here in-house, but then we do automated tests in a farm. So we use a device farm where we have around 200 devices, plus some virtual ones, and then we run those automated tests. Then those tests are actually gathered, and then we have some dashboards when we can actually analyze how the releases are going and how the changes that we are actually proposing in the game could affect or not the performance of the game. So we are doing a mix of different kind of strategies, but literally in-house, it's a little bit complicated to cover all the 3 billion users. I hope I answered your question.
You did, thank you. Thank you for that. Again, Peter, I want to ask you, someone asked a question. I'm going to ask you 2 questions, one from the viewer and one from me, and they're going to be kind of like opposite ends of the spectrum. So the viewer question was, is it enough to test your game performance only on low-end devices and be assured that it will obviously work well on high-end devices? What's the pitfalls in just doing that?
Yeah, I mean, so generally, yes. But I guess it comes with caveats. So I guess the biggest challenge we have with Android is there's a long history of devices out there which often include multiple generations of like hardware architecture version, let alone like within an architecture. So when we're still seeing devices shipping with GPUs that we designed the hardware back in 2012, like it's a decade old. We also have a wide variety of API versions, driver versions in the wild, and they're complicated stacks. They're not perfect. There's usually a variety of bugs or performance quirks out there. So in general, yes, I think if you pick a sort of suitably old low-end device and you have the same type of workload on your later devices as well, that's a really good proxy for your kind of baseline performance. More coverage is better. So obviously you've got GPUs from different vendors and different architecture flavors. Where you can, I would try and pick a kind of coarse sampling of different vendors and different architecture versions on the hardware side, just to make sure you have those covered. I guess the other one is just the kind of make sure you cover the different aspects of performance. So obviously GPU is part of it. That's where I spend most of my time. But you also have devices where you only have kind of Cortex A53 little cores. So not a great single thread performance, but quite good multi-thread performance. You may get devices where you have something a little bit off the wall, like very slow flash storage. So things like streaming resources become a problem, which you wouldn't necessarily get on a higher end phone with a faster memory device.
Right.
So there's a variety of kind of problem cases. It's kind of worth digging around a bit to try and get a kind of representative device of each. But as Ramiro says, there's so many devices on the market that you can't hope to cover all of them.
Yeah, sure. I'm going to come back to my second question for you because I want to add a little bit extra here. Paul, in your dealings with customers, for me, the thing that comes to mind, only testing on low-end devices, is if you're not frame limited, you could end up with something that's runs so fast that it's unplayable. Do you have that kind of experience when you're working with customers?
Well, it happens every once in a while, probably not as often as the opposite case where you're actually over frame budget, but it does so happen when we're working with customers that are really tight on performance, and they have maybe games that have simpler systems and simpler visual style. Mm-hmm. And one thing you definitely want to be careful of in that case is you don't want your frames to be running too quickly, ultimately, because as Peter, Ramiro have touched on previously, the implications on battery life is actually quite important in that case. So although a game running at 120 is really pretty, it will drain your battery a lot quicker than a game running at 30, for example. So you want to be careful of limiting your frame rate so that you can give processors more time to sleep. It doesn't have a huge impact on the actual like look and feel of the game. Most people are very comfortable playing a game at 30, even though it could potentially run a lot faster. Mm-hmm. So that's something that's really important to consider. You want to try and yourself throttle processing and try set your game to run at 30, even though it could be running a lot faster.
Right. Awesome. Thank you. So Peter, I am going to come back to that question I was going to ask you, which is kind of at the other end of the spectrum. And this could be a more general question that, other people could raise their hand about as well. But for you, Peter, we've been talking about mobile, right? But ARM provides chips for more than just mobile devices. There's tablets, there's, PCs, things like that. What are the considerations you need to think about when you're sort of profiling for multiple type platform targets?
Yeah, so I guess I can mostly speak for the mobile and the kind of more embedded systems like TVs and set-top boxes type environments. The big thing there is really just the constraints on different systems change, right? So and therefore maybe the bottlenecks you're trying to find are different depending on the type of system you're targeting. So smartphones tend to be more or less like a kind of computer. They've got a reasonably fast memory system. If mid-end up, you've got generally quite a significant amount of memory to play around with. But yes, there are vendor differences, but at least the platform architecture, no matter who your system's kind of GPU vendor is reasonably similar. Mm-hmm. I guess what we generally find is that certainly when we see content porting into high-end mobile from other platforms like console, is that the GPU architecture is different. So the algorithmic approach that you might choose on an immediate mode architecture is quite different to the way that tile-based GPUs would like to consume content. So there's often a bit of a rework phase when you're trying to port content between platforms. Mm-hmm. The other one is really just certainly for the more embedded graphics or Android TV type platforms, they have some different constraints. Memory is physically expensive to build. So an Android TV has very limited memory bandwidth, very limited memory capacity. So you're pushed a lot more towards asset optimization, really shrinking the size of textures and models, for example. You might get a bit more leeway on phone or a tablet.
Yeah, actually, you're right. Like I even thought about the Android, the Amazon, TV Fire Stick thing. You can play games on that. That's even lower end, I imagine, than a TV. Ramiro, I have one of my oddball questions I want to ask you. I love asking this question in different forms for game creators, which is the main question is, what was your favorite bug? So in terms of profiling performance, what was your favorite thing that you discovered while you were doing profiling? You were like, oh my gosh, how did we miss that? Or, oh, I can't believe that one little thing caused so many problems. Do you have any kind of story that you could tell like that?
I have so many stories that we will need a different webinar to actually go through all of them. But something funny that we found like 2 years ago, I think. So people was reporting that in some devices, of course, there was some stuttering while running. So I will assume that everybody plays Subway Surfer, so it's a runner. So you run in a, not in a subway, actually in a train rails. So people were seeing stutterings and we didn't know why. So actually I found that while running, we were actually updating the missions, so the progress of the missions, and writing to disk every frame.
Oof.
So at the end, and it took me a while to actually find it because it was very like random depending on the device, and how, as Peter said, you don't know how the disk works in every device. It depends on how powerful it is. But it was funny to see that we are actually literally stressing our game just every frame by changing a floating point. So it was chaotic. So now we refactor everything. So now we actually execute operations, we enqueue them, we write in a different thread. So we are not blocking the main thread at all. Yeah. But it was very funny when I found it, because I was expecting a rendering issue. I was expecting something normal, I would say, something less silly, that we were actually writing to disk every frame.
Sure.
And we were actually writing around 2 megas to disk every frame. So it was fun.
So yeah, so for those of you who haven't done a deep dive into how your game performs, disk IO is like the number one, like most expensive thing that I've ever experienced when I've been doing things. It's not the most efficient thing. So doing it every frame is, yeah, that would be an interesting experience. Awesome. Hey, Steve, I know you've been like champing at the bit. I want to ask you, I have so many questions for you, but I want to start with this question, which is, when do you know when to stop profiling?
That's quite an easy one, though. It's like, it's when you're within frame budget, right? Well, assuming that you're profiling for performance, I guess you stop profiling memory when you're within memory budget. Mm-hmm. Like, so with you know, the process here is you figure out what constitutes a sensible frame rate for the device that you're running on. On mobile, I would almost always say 30 frames a second. I know some people come from like PC dev and console dev onto mobile and like, we're going to make our game run at 60. Well, yeah, but the phone's going to melt, right? Like, unless you get it very, very optimal, yeah, or unless you're doing something very, very minimal. Sure. So you choose your budget, you know, maybe a 60 console is what, 120 on VR, depending on the platform.
Sure.
You know, you maybe like adjust this, you figure out what that is in milliseconds. You maybe adjust that down if you want to allow yourself some leeway, particularly on mobile. We have this kind of weird rule of thumb at Unity where we tend to recommend like leave about like 35% of your frame budget. So we're with the CPU and the GPU idling to allow the chip's time to cool down. I looked into how we arrived at that number and I'm not entirely sure. It's just one of these kind of like I'd love to hear Peter speak on that at some point. But, you know, eventually you arrive at a budget. Once you're consistently under that budget, like move on. Like life's too short to spend time like micro optimizing this thing into oblivion. Like, you've got features to build, you've got polish to add, you've got bugs to fix, like you've got other things to do.
Yeah.
So yeah, like it's not, you know, I think there definitely is a point that you can kind of put the profiling tools down and step away and just remember to come back to the profiling tools maybe next sprint or like, you know, in a few weeks, just to make sure that things are still kind of fine. This is the thing, once you're on top of the frame rate and your memory usage, profiling sessions can get really quick because they're just like, you fire up the profile out, you look at it, you go, yep, that's fine. that's you done for another
Yeah.
couple of weeks, you know.
Yeah.
So-
Ivan in the chat said, "You stop profiling when there are no more complaints."
Yeah,
Could
that's
be
a good answer.
good
That's a
benchmark.
more concise answer than the one that I gave, for sure.
Daniel asked, and I'm going to throw this one to you, Peter. Between CPU usage and GPU usage, is one of them a greater contributor to heat generation on mobile devices than the other?
So it's really going to depend what your content's doing. So, you know, I guess it's for mobile, it's a system budget, right? You've got about 2.5 to 3.5 watts for memory, display controller, GPU, CPU. If you have a game which is pushing a lot of rendering, then it's pretty much guaranteed to be GPU. Because GPU is data plane, that also tends to come with a fairly heavy DRAM power cost, and we'll probably touch on DRAM later if we have time. That's a whole webinar by itself. CPU, again, I mean, if you can multi-thread, kind of, you've got multi-core systems running 2 or 3 cores more slowly is much more efficient than 1 core running very fast.
Yeah.
But yeah, you know, if you have a high-end ARM system with, you know, 4 big cores and 4 little cores, and you're using them all flat out, you're going to overheat the device just on CPU. So yeah, it really does depend on your content and the balance of CPU work to GPU work that you're doing. But they're both enough by themselves if you push them hard enough, unfortunately.
Yeah. Okay, I'm going to toe the company line for a second and say, hey, look, Unity's editor tools and profiling tools are fantastic. And then I'm going to deviate, but they're maybe not enough, right? So Peter, and then someone actually just asked about some of the ARM tools as well, and Mali offline compiler and things like that, and maybe integration into Unity. What kind of tools do ARM offer Android developers, for example, to help with their Unity games?
So we have our ARM Mobile Studio tool suite, which is a collection of tools. The main one is our Streamline Profiler, which is a sample-based profiler for CPU and GPU. It's sample-based, so it's very lightweight. Even in a running game, it's generally only 2 or 3% CPU overhead. It's very good for kind of GPU profiling. You get counters out. We can capture dozens of counters simultaneously. The one thing it's not great for is ironically Unity. Obviously, it's a .NET based compile. We don't yet understand the sort of C++ to .NET translation in Unity. It's something we're looking at. But like, if you're happy with the Alta CPP C++ symbol names, it can profile Unity, but you have to squint a little bit. So that can give maybe an alternative to the instrumentation based profiler that Steve mentioned earlier. It has less visibility because we're just taking samples every millisecond, but it does have a much lower overhead in terms of impact on the running game. We have a kind of wrapper tool around that called Performance Advisor, which is really about reporting in continuous integration type environments. As Ramiro says, a lot of companies have these device farms. You don't want to pay a human to go and review performance across 200 devices every day. It's too expensive. So how do we take the data and report on that efficiently? You can just look at dashboards and metrics and go, yeah, it's all good. Let's move on with our day. And I'd ideally do that automatically. Mali Offline Compiler is a kind of static analysis tool for shader code. So you can take a single shader stage, run it through the offline compiler, and it will give you metrics about which pipelines are being used and how much they're being used. Maybe some feedback about things that you're doing that we would or wouldn't recommend. So that can be useful for seeing how shaders run. The nice thing with it is you don't need the device. You can specify any Mali GPU from the last 10 years and get some stats out. So you might have a device, and then you can maybe extrapolate from that data point how well it might work on a kind of similar but not quite the same GPU. And that's quite good for kind of quick iteration. You haven't even got to build the game. Just give it your shaders and see how things go. Yeah,
cool. Thanks for that. Hopefully, and I know Thomas added a comment in the chat for those of you watching, to get the ARM tools from there. And I'll have a slide up at the end where you can get in touch with Peter directly if you have other questions on that. I actually do want to throw, it's not in the Q&A, it's actually in the chat. And Paul, I want to give you a chance to come off mute. Rupert actually was like, hey, why has no one talked about environmental implications? Does your game need all of these frames? We throttle based on activity, but what about making sure we are targeting, not just the best experience, but the best experience for the planet as well? Do you have clients you work with that have that as a factor in their profiling?
It's probably come up once or twice. It's probably not the biggest concern, but I think it's super valid, definitely. It's something to be considered. I think we could all do a lot better as software engineers to try and improve our footprint at that level.
Mm-hmm.
But yeah, definitely a good point. Steve?
Yeah, awesome. Yeah, Steve?
Yeah, I wanted to put my hands up there and say that like my previous answer, not taking environmental concerns into account, was wrong. Like if you're within frame budget and there is like some low hanging fruit where you can go, I can just untick a checkbox and that's 5 milliseconds. Like, absolutely go do that. It's like it kind of comes down to how much work is involved and how much like time you save for that work. But if there's low hanging fruit, then yeah, absolutely do it, because all of those watts add up,
Yeah. Frames cost energy, I think is what you said in the chat. Yeah. Hey, Ramiro, I've been watching you on the video and knowing that you've been wanting to talk some more. So I wanted to ask you, I asked you about, your sort of favorite bug, but in the same sort of vein, like what's your sort of most valuable learning that you would have to share with other game creators watching on profiling and its impact to your business?
At least for me, as I said before, when I started working for Cyber, and then I started facing the Android platform, the reality behind it. That was the biggest learning, that all the assumptions that I had were all wrong. So all the assumptions regarding how the hardware works, how the combination of the hardware can affect your game, how the geographical implication and how the devices, the distribution works. So I think that was the biggest change for me. So I actually started taking profiling and the impact of it for the game in a different way when I started working for Cyber. So I never have seen those kind of implications in my other games because we were not as big. So mostly when you're actually checking the Subway server, the users are very active, so they're very vocal about how the game is actually working or not working as well. And you can see how the reviews and how the feedback in the different social networks is actually suffering of any kind of lack of profiling or lack of action from our side when it comes to how the game is actually performing.
Mm-hmm.
So I think that basically it's Android. Android is a new universe, and I discovered it here.
Yeah. At the risk of me being fired, what other sort of profiling tools or performance sort of optimization tools and experiences do you use outside of Unity, or do you just use Unity and the ARM tools? Anything else you use?
We use a combination depending on what we are actually trying to find. We always start with Unity because that is the most accessible one and is the one that you have right away in your computer. Mm-hmm. Then, depending if we are actually testing on Android or iOS, we will go to Xcode, we will go to Android Studio, we might go to Intel GPA if you want to check some specific stuff. We will go to ARM, depending on the architecture of the device. So we try to combine them because we don't want to. I will correct myself. The best learning that I have is don't assume. So assumptions are the worst mistake ever. So I will say that is the best learning. So don't assume anything. So we try to cover all the different tools at the same time, depending on what we are checking.
Yeah.
So I think that is the best learning, actually.
Great. Thank you. Steve, you were one of our co-authors of the ebook that we've kind of hinted at a few times during this call. And we'll have a link up for that ebook at the end of this webinar as well for all of you to be able to get access to it. But I want to talk to you about the process of using the profile and stuff. So I'm going to share my screen again because you have this great flow chart, and I was hoping you might sort of be willing to sort of talk through it just for a couple of minutes.
Yeah, sure. So like I think this is like a core part of the ebook, the first version of this I did in Post-it notes on my kitchen cupboard, but it looks much nicer in the ebook. But what I wanted to do at the core of the ebook was to for people that maybe aren't used to using profiling tools or that haven't done it very much before, to do as much as we could to demystify the process, right? To say, like it's to go on to Ramiro's point about assumption, like this is what profiling tools are for. They're for checking your assumptions, they're for finding out where the actual bottlenecks are, and that then lets you go and act and optimize in a focused way that's actually is gonna help you. Mm-hmm. So I tried to do this this flow chart just to kind of talk through like what my process is when I'm looking at customer projects and what I think would be kind of useful. So we start at the top where we kind of just check the Unity profiler as a first thing, like see if we're in frame budget. If we are, that's great. Let's go look at memory and move on to that. But if we're looking at performance, the next couple of sections on that flow chart are about finding out from looking at the Unity profiler where the bottleneck is, right? Like, is it the render thread? And if it is the render thread, is that because the render thread is waiting for the GPU? Or if it's not the render thread, are we waiting for the main thread? Are we waiting for workers? Then this what now section, depending on what your answer to that question is for your game, these are maybe the next tools or the next things that might be available for you to go and investigate more deeply into what the causes are. And I make some very broad speculations as to what the fix might be in terms of, like, if you're GPU bound, maybe that's a thing to look at fragment shaders. If you're CPU bound, main thread, maybe that's more about your game script or something. Like you're not going to improve GPU performance. It's unlikely that you're going to improve GPU performance by making changes to your game scripts and vice versa. Mm-hmm. So yeah, I think this is just trying to kind of define what the process is, and then following on from this in the guide, and also in the kind of blog post that like accompanies the guide, there are some images of like, here is what the Unity profiler captures look like for various real world projects that have bottlenecks in these different areas. And that's just about becoming familiar with how games look, and specifically how your game looks, viewed through the lens of the profiler, so that you can start to see how you can start to identify what happens when that deviates away from like optimal performance.
Cool.
I think that's my answer.
Thank you. And Thomas again has provided some links in the chat too, including a full resolution image of that chart I just showed, in case it was a little small for you on the webinar screen. Ramiro, I wanted to ask someone asked a question that was for you, and now I've lost it. Okay, here it is. Can Ramiro talk a little bit about other KPIs such as load time, memory usage, response time, things like that, and how they factor into optimizing games?
Yes, I can say that as Paul, Steve, and Peter, both, all of them were actually talking about the frame budget and how that impact the game is. So when we are actually profiling the game, we are actually measuring all these things. So we need to know exactly what is the rendering time, what is the any kind of delay that the input can suffer, the CPU time. In the chat, people is asking about when the GPU is waiting for the CPU or vice versa. So we need to analyze all those things. So in general, when we are actually checking the frame budget and we are analyzing what is the cost of each thing, we try to calculate exactly how each piece of the frame is divided, what is doing what, and from there we are actually taking it to optimize it. KPIs in general, you have, like, for example, if we are measuring rendering, Steve was talking, not sorry, I think that Peter was talking about shader, for example. You can actually calculate how is the complexity of the shaders. In our case, at one point, we were actually checking batching, how many draw calls you have, how many set passes you have per frame. And all those together are actually what we, at the end, are actually measuring to calculate what is the impact by profiling the game. So in our case, for example, right now, we ended having an Uber shader in the game to control all the materials. We try to minimize the amount of materials. You can actually set up the render queue in Unity. That is a very useful thing to allow Unity to render things in the proper order. So we decrease the fill rate, and we actually decrease the set comparison and pixel comparison when drawing. There are a lot of different metrics that we can talk about, but in general, those are the ones that you are measuring. The same with someone in the chat was asking about, for example, the latency when clicking something that it comes from Android. So those are things that we need to contemplate more towards the idea that our game needs to be responsive, because people is swiping around and jumping and all that. So we need to minimize the impact of any kind of external source in the gameplay itself. You're on mute, Andrew. Sorry.
Sorry, it didn't come off. Okay, team, we're running a little low on time, so I'm going to ask you guys all like kind of one more question each. I'll ask Peter, do you have a final sort of thought? And I might have some time for Q&A. I just want to make sure you guys all have a chance to speak one more time. So Peter, do you have any sort of final thoughts?
Yeah, so I guess the one that I would always suggest to people is, like, the initial focus on this is nearly always the 3D rendering. Don't neglect your 2D UI overlays and those aspects of your game as well. So people optimize for the 3D part, it's nicely hitting 60 FPS. Then someone goes and puts a blended UI overlay over the top, and then it's suddenly not hitting 60 FPS anymore. So think about your kind of worst case 3D behavior, and then add on top your kind of worst case overlay behavior. That should be the scenario that you want to optimize for if you're trying to stop dropping frames. So yeah, this definitely isn't just a 3D problem.
Good point. Good point. Cool. I'm going to switch to the Unity guys, and I'm going to share my screen while I do that. Paul, do you want to go first?
Yeah, can you repeat the question, please, Andrew? Sorry.
Just any sort of final thoughts. We're only a few minutes left, so I want one sort of final tip or insight that you wanted to sort of add to the conversation.
Yeah, I'd say just it's pretty basic, but as Ramiro mentioned, always rely on data and never make any assumptions about where your issues are. I've seen this too frequently. So definitely get used to the tools. Pardon me. Get used to the tools, and I'd say another thing is don't be intimidated by the data that you're going to be getting from these tools. It can be a little bit intimidating at first because there's a lot of concepts to learn, but allow yourself to experiment, get the hang of it, and in the end, you will end up being a better software engineer, and you're definitely going to be able to work miracles and improve performance across the board. So experiment, and it's okay to be intimidated. You will learn stuff. Check out the guide. It's actually super helpful to get started when profiling.
Awesome, thank you. And Steve, I've got this up on intentionally because the question for you is a little more targeted. Is what's your favorite sort of top tip out of the ebook or any area that might help people?
Oh gosh, one top
tip. Just
tip.
one. I'm putting on the spot. Just one.
Okay, so like there are a whole bunch of tools that are available to you to profile that do that do different things, right? Like, so it's a toolkit and you choose the right tool for the job. But one of my favorite tools that I think is overlooked a lot is the profile analyzer. The guy talks about that a fair bit. It's really good for comparing Unity profiler captures to each other. So you can, like, before and after an optimization to see whether or not that helped. But actually, just to take a single capture and aggregate that data together. So instead of looking at a frame at a time, you look at 300 frames or 2000 frames. Mm-hmm. That is a super useful way to just look at the same data in a different way and maybe surface some different things. So there you go. Like, there are lots and lots of tips that I would like to highlight, but like, that's the first one that sprang to mind.
We only have like 2 minutes left, Steve. So sure. But obviously super passionate about profiling. The ebook's fantastic. Big deep dive there. And then Ramiro, one last thing from you, if you have anything else you wanted to say.
Yeah, of course. I have only 3 minutes. So just don't give up. The learning curve of profiling is terrible. But at the end, you will find it fun. So just keep trying, as any kind of a skill, like learning music or learning programming is like, at the beginning, it's horrible. You don't understand anything. You get confused. You want to quit. Don't do it. So you have to find the entertainment behind it. And actually, when you see the results, it's amazing. So just don't give up.
Just look for the biggest number and figure out how to make that number get smaller. Can't go wrong.
Yeah. No, and that's the life of a developer or creator, right? Is the highs and lows where you spend all day trying to fix a bug, and then you spend 2 hours doing more code than you've done in the last 2 weeks. No, I totally get it. So, hey, my last slide here, contact information for all of us. These are all Twitter handles. Mine actually is everything I could do in life: gamer tags, Twitter, LinkedIn, wherever you want to find me. But Paul, Peter, and Ramiro provided their Twitter handles as well. You can reach out to them directly, and they'll be very happy to answer you on those. Steve, a little more old school or formal, however you want to define it. He's on LinkedIn. Same thing though. So there's that. The ebook is available on resources.unity.com/games. And there's a lot more information on there as well. So just dig into that. There is some sort of profiling stuff. I saw someone ask a question on Unity Learn as well. There's a bunch of things going on. The ebook is a great starting point. We'll have some more profiling things as we go through the year. So look out for those as well. And with that, I think I'm going to say thank you, everyone. Thank you, team. Thank you, audience. And have a great rest of whatever part of the day you're in. Thanks, everyone.